What's up, interweb? Okay, I'm gonna have to go kind of fast because this recorder won't let me uh, go on forever and ever. So, first thing we did, this is from class from Tuesday the 15th, evaluating rational expressions. This is real simple. If you're given this rational expression here, uh, evaluate for x equals 3. So wherever there's an x, we're going to plug in 3, and we get this. 3 times 3 plus 6 over 2 times 3 minus 4. Now remember, this is just order of operation, but remember that the fraction bar acts like the numerator and denominator are in parentheses, so we're going to do that first. So we do 3 times 3 is 9, plus 6 is 15, I think. And the denominator is 6 minus 4, which is 2. So our answer is 15 over 2. I'm not going to spend a lot of time on this because it's very simple. Okay. Now, what we do have to do is we cannot have 0 in the denominator, because that would make it an undefined. 0 in the denominator makes the expression SSION undefined. Okay, if you have a 0 in the denominator, makes the expression undefined. So if we have this same expression here, 3x plus 6 over 2x minus 4, what would make this expression undefined? What would x equal, excuse me, to make this undefined? The only thing we have to worry about what will make this undefined? The only thing we have to worry about is that this is not 0. So how do we find out what value of x will make this undefined? Real simple. All we do is we make 2x minus 4, and we set it equal to 0. Add 4 to each side. Now we have a real simple algebra problem. 2x equals 4, divide by 2. So x will equal 2. Actually, x cannot equal 2. So if you put 2 back in here, 2 times 2 minus 4, 2 times 2 is 4, minus 4 is 0. And we cannot have 0 in the denominator. We can have anything else, any other number in there could be 0. Well, that's what that is. Now, okay. Write the rational expressions in lowest terms. Okay. Now look, what if we have this? If we have, excuse me, x minus 5 divided by x minus 5, what do we have here? Remember, these are acting like they're in parentheses. Is any number divided by itself is 1, right? Any number divided by itself is 1. So what do we have here if we have this? If we're given that 3x minus 12 divided by 5x minus 20. Now, what can we factor out of the numerator? What number can we factor out of this? 3, right? 3 will go into this term and this term. So it's 3 open x minus 4, right? I do this backwards also to make sure I'm right. 3 times x is 3x. 3 times the negative 4 is negative 12, so we're right. And what can we factor out of here? A 5. 5 will go into both of these terms. So we have 5 open x minus 4. Okay, x minus 4 divided by x minus 4 is 1, so we can just cancel that out. Actually, it's going to be 3 times 1, which isn't going to make any difference in our value here. And that's all there is to it, right? Right. Now, what if we have this? This if you're so damn smart. 2y squared minus 8 over 2y plus 4. Okay, now what can we factor out of this? A 2, right? 2 will go into both of these terms to open y squared minus 4. What is this? A conjugate. I hate to say I told you so, but I told you so. That we're going to use these conjugates and look for them. Divided by, what can we factor out of here? A 2. To open y plus 2. Now we can factor this conjugate into 2 open y plus 2 times y minus 2, right? Remember, always look for these conjugates because it's going to save you some time and money. And this one in the bottom is, or in the denominator, y plus 2. Okay, we can cancel out the 2's. And again, I'm sorry for going so fast, but you can stop and start this. You know better than I do. And y plus 2, y plus 2. So what are we left with here? Y minus 2. Okay? Okay. Same thing if you were to factor, let me do one more of these. What if we have this? X squared minus 7x plus 10 divided by 3x squared minus 75. Okay, remember, when the linear term, the middle term is negative, and this one's positive, it's going to equal, the two factors will be x minus something and x minus something, divided by, what can we factor out of this? The 3. 3 will go into both of these terms evenly. X squared minus 25. Again, look what we have here. A nice pretty conjugate. Okay, so what are the factors of 10 that add up to negative 7? We have negative 1 times negative 10, negative 2 times negative 5. There it is, there, isn't it? Minus 2 and minus 5. Right? Right. Now, stupid boy, x minus 2 times x minus 5 divided by 3 open. This is a conjugate, so it's going to be x plus 5 times x minus 5. Okay, the x minus 5s will cancel. And that's it, huh? So we have x minus 2 over 3x plus 5. Now, in my math lab, if you're doing the same thing in my math lab, they may want you to open. Sorry, I'll do better. Okay, they may want you to go ahead and do a distributive property here. So this could also equal x minus 2 over, and distribute the 3 over everything in here. 3x plus 15. Right? Right. Okay? Yeah, these are not difficult. They're just a little different and fun too, huh? Yeah, that's good stuff. Okay. Now we're going to do inequalities. Inequalities. E-Q-U-A-L-I-T-I. Inequalities. What does that mean? Not equal, right? Greater than, less than. Okay. Now, if we have x is greater than -3, can x be -3? No. It's all the numbers down to -3, but not including 3. So now, one thing I want to do here is if it's less than or greater than, we use parentheses. If it's less than or equal to, greater than or equal to, we use brackets when we graph. Okay, so x is greater than -3. So if we were to graph it, it would be 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. -3 is 1, 2, 3 right here. Now we're talking about x is greater than. This way, you know, the numbers get bigger this way. This is greater than, this is less than. So if x is greater than -3, what do we use? Do we use parentheses or a bracket? Parentheses, greater than. Okay. And what numbers are greater than -3? All of these numbers. Now we have a thing, that's the graph. Now we have a thing called interval notation. I-N-T-E-R-V-A-L. Interval notation. Okay, interval notation mimics, is basically this graph, but shown in like this. Okay, what's the least number this could be? What's the lowest number? -3. Okay, do we use a parenthesis or a bracket here? Parenthesis, because it does not include the number -3. It's all of these numbers up to, or actually down to, -3, but not including -3. And then what's on the high side? What's the most this number could be? Positive infinity. With the, again, with a parenthesis, because infinity does not end. Okay. Now, what if we have this? What if we have that x is less than or equal to 2? First of all, let's graph it. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, -5. 2 is right here. And now x is less than or equal to 2. So are we going to use a parenthesis or a bracket? A bracket. Opening which way? That way, because it's less than. So what's on the low side? What's the least number this could be? Negative infinity with a parenthesis. And what's on the high side? What's the most this number could be? 2 with a bracket, because it includes the number 2. If you'll think about money, if I said that I have less than, well, let's not do that. If I said that I have less than or equal to $2, could I have $2? Yes. And, or let's do this. What if I said that I have, my money is greater than $2? Greater than. What's the least amount of money I could have? $2.01, because it does not include the number 2. Okay, And that's all of that. Now, when we solve inequalities, N-E-Q-U-A-L-I-T, to solve inequalities, you do this just like equations, with one exception. Always an exception, it seems like. If you multiply or divide by a negative number, I got a hair on my pen. N-E-G-A-T-I-V. By a negative number, the signs flip. By the signs, I mean less than, greater than, less than, equal to, greater than, or equal to. If you multiply or divide by a negative number, the signs flip. So if you have this, and again, you solve these just like equations. So if we have 3a is greater than or equal to 6. How do we solve this? A very simple algebra problem. Divide by 3, or a. Okay, did we divide or multiply by a negative number? No. So the sign remains the same. 2. Now you graph it. 1, 2, 3, 4, 5. 1, 2, 3, 4. Negative 5. Okay, here's 2. Now a is greater than or equal to. Now if it's greater than or equal to, we use a bracket because it includes the number 2. Goes that way. Our interval notation, what's on the low side? What's the least this number can be? 2. Excuse me, with a bracket. What's on the high side? Infinity. With a parenthesis. Right? Right. Okay, again, I apologize for going so fast, but I only have a limited number of minutes on this this thing. Okay, now what about this? Get this if you're so smart. Negative 2b. Look, this is multiplying by a negative number, so we're going to have to divide by a negative number. So you know our sign's going to flip here. Plus 3 is greater than or equal to negative 9. Look at these godless negative numbers. Okay, so the first thing we do is, remember, we get rid of addition, subtraction first. We do PEMDAS backwards when we're solving equations or inequalities. Subtract 3 from each side. Negative 2b greater than or equal to, what was that, 12? Negative 12. Now we're going to divide by a negative number. I'm going to divide by negative 2. That means that this sign is going to flip. Is it going to equal, what is it? B now becomes less than or equal to negative 12 divided by negative 2 is a positive 6. Okay, and our graph will look like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Negative 5. Okay, here's 6. Now less than, B is less than or equal to, less than, again, less than is this way, greater than is this way. So less than, we use a bracket, and it goes that way. Now, when we do our interval notation, what's on the low side? Negative infinity with a parenthesis. What's on the high side? 6 with a bracket because it includes the number 6. Right? Right. Okay. Now this is about as difficult. Well, no, there's one thing that's a little more involved, but really not much. If we have this, if we have 5c, first take a drink. Mm-hmm. Okay. Remember, when you have variables on both sides of the inequality here, move the variables first. Really doesn't make any difference, but this will make it so you don't have any godless negative numbers somewhere. So subtract 3c from each side. Take the smallest over to the biggest. 5c minus 3c is 2c minus 2 less than 4. Now we add 2 to each side. 2c is less than 6. Divide everything by 2. C is less than 3. Okay, now when you do the 1, 2, 3, 4, 5, 1, 2, 3, 4, negative 5, here's 3, 1, 2, 3. Now C is less than, so we're going to use a parenthesis opening this way. Now our interval notation is, what's on the low side? Negative infinity. You got negative infinity on this side and positive infinity on this side. Negative infinity with a parenthesis because it never ends. And on the high side, the most this can be is 3. Again, with a parenthesis. 15 minus 2 is 13. Yeah. Okay. Okay, this is called set operations. ERATIONS. Set operations. If you have the set of numbers given the set of numbers that A equals 1, 2, and 3, and B equals 2 and 4. Now, if you have A union, okay, this means union. In other words, it's this number and these numbers all together. If you have A union B, it includes all of the numbers here. So 1, 2, 3, and 4. We don't have to put the 2 again because we've already got it. This is a bracket or a brace here, not. Okay? Now, what if we have the intersection? If we have A intersect B. Intersection means what numbers, just imagine we've got, let me see if this works at all. These are streets. Pretend these are 2 streets. And A is 1, 2, and 3. And B is, this is A, and street B is 2 and 4. What numbers are in the intersection? The intersection is just like the intersection out in the road in the street while we're driving. What's in the intersection? 2. Right, right. I hope that makes a little more sense than intersect. Now, what if we have this? Okay, what if you're given that A is 1, 2, 3, 5, and B is 7. Okay? A union B is all of the numbers, all of them. So it's 1, 2, 3, 5, 7. All of them. Now, A intersect B, which numbers are in both of these? None. None of these numbers are in the same sets of numbers. So our answer here is a 0 with a line through it. That's called the null set, or the empty set. Okay, typically we call it the null set. Okay? All right, that's all we have. We shall do more of this next time. Okay, y'all take care. Bye bye. Bye, bonds.